Recording in progress.
Yeah.
I'm just downloading now.
Okay. Cool.
Meanwhile, can we go through anything?
Yeah, we can go through something. So I think you also need to install Rust.
Okay.
Yeah, so maybe you can get Rust. It's something called Rust up, right?
Rust up. Okay. Retailer. Oh, okay. And anything from this?
Yeah, cool.
So then proceed with installation. Okay. Yeah, I think the default. Okay. We have Docker installed here. Application. Also, William,
Yes.
okay, I'll just note it down because the next person is onboarding next week, right?
Yeah.
So it will help them. Okay, I think we have everything running.
Mm-hmm.
Yeah. So Docker is there. We just need to install like yeah.
Okay.
Yes.
No.
Awesome. Meanwhile, we will also look into Rust. I think it's installed now. Rust is installed.
Sorry.
Rust is also installed.
Okay, cool. Yeah, I think you need to get the tool chain. Let me see. Let's try. Let me just send you the commands.
Mm-hmm.
Yeah. Do you have a preferred editor?
Mm-hmm. Yeah, the editor you were talking about. Rust up. So,
You have to kind of. Um. Did you install? I think you need to. You. Yeah, you might need to. Yeah, you might need to add. Um.
to path variable.
Yeah.
Okay. Yeah.
Okay, and then proceed with.
Awesome.
Uh huh.
So done. So I'm using VS Code.
Okay, I think VS Code has you can get the extension called Rust Analyzer.
That's is this one. Yeah.
Okay, cool. All right. So what I'm gonna do is kind of so you've got a chance to play around with Terra Station, I believe.
Yeah.
I think what we're going to do is we're going to just go over just a smart contract to kind of understand, how it's laid out, and then we're going to edit that smart contract a little bit and really kind of see if we can make or kind of add some new features to the smart contract. Yeah. So why don't we? Why don't you go ahead and go into or just go to your workspace directory.
Mm-hmm. Let's hear. Hello, world.
Okay, yeah. Why don't so in the terminal you should type. Um, okay. Oh, you should do cargo space install space cargo dash generate.
Was not found. So,
Yeah, I think you need to add that. You know the environment in your
let
Z shell.
me check.
Yeah, so you need to
No. And how do we do that?
maybe you need to add home dash dot cargo slash env into your like Z profile.
Mm-hmm. So is it wasn't this one?
Mm-hmm.
So
Now you might want to
where is
add
it?
that in. Yeah, yeah, and I think yeah, you need to add that into like your Z or Bash profile. I think since you're using Z shell, like just add
Uh-huh.
add that to just like Vim.
Okay, I think I need to look this up. Can you look this up?
Sure.
Yes, wait for a second. Okay, and does cargo works here? Oh, it works. It does. This should work. No, oh, okay, okay. I think, yeah,
Um, do you have an extra space?
I had an extra space.
Yeah, yeah. See, source home dot.
Okay. Yeah, sorry.
Yeah, why don't you just add it to your path through like Z profile?
Yeah, I'll do that. Uh, the parts.
No, you just need a yeah Vim like dot Z profile and then just add that.
Okay, I can. I'll do it. Is it night? It must be night for you.
Yes, it is night.
Okay, I think it's done. Okay, so still building cargo generator. So what is cargo over here?
Cargo is like the npm for Rust. It's also your
Oh,
build tool and the package manager.
okay. Okay, so over here, and does it create any sort of like package.json?
No, what we did was just we added it to your cargo. So right now we just added a binary. So this is like a npm install -g.
Mm-hmm.
Right. So it's something called cargo generate. So now you can run the command cargo space generate.
Okay, space generate.
No, no. Let me give you the full command. So it's cargo space generate space dash dash git. Well, let me just type the command for you. You should kind of memorize this.
So William, you have been into crypto world since starting of your career.
Sorry.
So you have been into crypto world since starting of your career.
Um. Yeah, maybe before that, I was in like my second year of high school. I got into Bitcoin,
Mhm.
and I've been in the crypto world since like 2014.
Oh my God.
Yeah.
So we have all the everything generated. I'll just save this.
Sure. So basically, there's a template file located at the Git repository, and then that just generates like a starter contract with all the boilerplate. Right.
Okay. They have all the instructions here, right?
Yeah.
Okay, awesome. So what next? Yeah.
Okay, so I kind of give you a tour of the things. As you can see, there's a lot of stuff. A lot of them are markdown files. You can just leave them there. The where you're going to be writing your code is going to be in the source directory,
Mm-hmm.
right? So you can see there's a lot of code, like and so what these are individual modules. So how Rust likes to organize code is called using a module. So when you declare a module, you kind of can split out your code into different sections, right? So each file right here represents a module, and where those modules are combined are in lib.rs. So
Mm-hmm.
if you go to lib.rs, you can see where all the modules are declared and defined, right? So then, okay, let's just do an example. If you change the line 3 pub mod helpers, if you change that to helpers E, you will complain
Okay, and how
because it can't find that file. So if you type in cargo wasm.
good awesome.
Oh, you need to go into the hello world crate,
Oh,
right?
yeah.
Okay. The reason why there's as you can see in the top, there's something called dot cargo,
Yes.
right? Dot cargo is just some place where you can put some aliases, um,
Mhm.
right? As you can see, it's
Oh,
actually
okay.
build dash dash release dash dash
Yeah.
target wasm 32 unknown unknown, right?
It's like a script in the package of
Yes,
JSON.
right, right,
Okay. So we have it's complaining here that this module doesn't exist.
right, right.
Yeah.
So that's why um, that's what those modules have to correspond to the file name, right?
Mhm.
Okay. So as you can see in the help message, to create the module helper C, you can create a file. So the file could be the module, or you could create like a directory and then declare that it's a module by making it mod.rs. So in short, how you create like these modules are either directly in code with the mod keyword, um, or with or by creating a file of that name, .rs,
Okay.
or creating a folder of that name with a file named mod.rs. Okay, let's
Okay.
go into. So why don't you fix that in lib.rs again?
Yeah, sure.
Okay, right. So lib.rs. So in a Rust crate, so Rust packages are called crates, right? Crate
Mm-hmm.
cargo. Um, your crate can be one of two types. It can be a library or an executable. If it's a library type crate, then you're going to typically find that the entry point, it's like index.js, right? The entry point is called lib.rs.
Okay.
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 In a binary crate or executable crate, like a program, the uh, the source file is going to be called bin.rs, right?
Mm-hmm.
So it's just to keep note. So how do we know that this is a library crate? So if you go to cargo.toml, which is the package.json,
Cargo.trauma. Okay.
all right. So this is kind of where it's declared. So let me go through each section. So if you look at the top, we have package name equals hello world version. This is the metadata, right? We can keep going down and look at the lib section. As you can see, it's declared to be of a type lib, right? So the crate type, you can see there's two crate types defined. It's cdylib and rlib. So
Mm-hmm.
cdylib is a C dynamic library, and rlib just means Rust library.
Mm-hmm.
So why we put cdylib here is that every time you're going to be targeting WASM, you're going to be wanting to target or you're going to be basically creating a C library.
Mm-hmm.
Okay, so for the others, you can just ignore, but go ahead and look at the dependencies. Right. So we have cosmwasm-std, cosmwasm storage plus, CW2, all these like different crates. So basically, the cosmwasm API is imported.
Mm-hmm. Okay. So all the dependencies are mentioned here. Mm-hmm.
Right, right. Okay. So let's kind of step through the structure of the crate. So if you can go back to lib.rs, let's look at the different modules. So there's a module called contract, a module called errors, a module called helpers, a module called integration tests, module called message, state, right? So you can go ahead and just comment out lines 3 and 4.
Mm-hmm. Right. Okay.
Right. The reason
Should I
I
compile?
asked you to
Yeah.
comment, yeah, sure, you can try. So cargo wasn't.
Correct.
Okay, cool. So, um, okay, pubmod means to export that. So basically, all contracts are crates, right? So imagine every contract being its own like um, npm package, right? So
Mm-hmm.
then, in the future, somebody wanting to use your contract code might be able to just import some stuff from your contract, right?
Okay.
So
Mm-hmm.
what are each of these sections, right? You want to comment it to kind of guide you. So the first module is called contract, right? That contains the contract logic,
Okay. If we go into, oh, we can't directly go there. Okay.
right? This is where the contract logic is contained. Okay.
Mm-hmm.
If you go into message,
The message. Message.rs, you're saying?
yes.
Okay.
If you go into message.rs, you can see that here we define a couple structs and enums, which are just custom data types, right? But canonically, we conventionally use the names instantiate message, execute message, and query message.
Mm, okay.
Okay, so each of these corresponds to a interface or a function signature, right? So can you
Mm.
guess what does this contract do based on these signatures? So I've not explained what instantiate does or execute or query does, but maybe you can guess by the message types and message names. Do you think what does this contract do?
It basically it's used for querying and executing the message. So if you it returns like over here it is written get counted and then count is a JSON recorded. It's,
Yeah, but trying to so I haven't explained what instantiate, execute, and query are, but judging by this contract, can you kind of guess what does this contract do?
so there is a snake case, right?
All those you can just ignore. The these are something these are called derived macros. They basically implement something called traits. You know, for it's like automatically implementing certain functions for these data types. For
Okay.
instance, like uh, debug allows it to be printed. Clone
Mm-hmm.
allows this data to be cloned, right?
Mm-hmm.
So those are macros, right? And this just
So
consider it boilerplate for now. Just focus on what each of the like
yeah,
instantiate message,
yeah.
execute message, and query message. So
And
what do you think this
so
contract does?
I think it's a kind of a broker chain where you like instantiate a message, then execute it, and then someone's queried.
Right. Right. So you can think of a contract sort of like a singleton object that lives on the blockchain,
Mm-hmm.
right? So instantiating means to create that singleton object, right? And that lives like at an address in the blockchain. So once you have that contract address, you can start executing and querying things to it, right? So if you
Mm-hmm.
take from like for example Java analog, right? Um, so in Java, like assume that these execute messages are like functions that change the state of the contract, right?
Mm-hmm.
So the execute messages are like functions that update the state of the contract. Query messages would be analogous to what?
Query message would be. Can you repeat that again? Like execute message would be analogous to.
Would be analogous to a function that changes the state of the contract.
Okay, and query message would be like getting the message, right? Getter.
Right. Exactly. Right. So the difference between execute and query messages is that execute can change the state of the blockchain, whereas query message is read only.
Yeah, it's a getter. Yeah.
Okay. Right. Okay, so let's go into state.rs and kind of see what is defined in state.
Okay. In state, we have the count and the owner.
Mm-hmm. Right.
So count, I guess count is like number of messages instantiated by the owner.
Yes, but this is so we don't have we haven't looked at the contract code yet, so we can't really tell. But judging
Mhm.
from this, it seems that we're saving the state of the contract contains two things.
Attributes. Yeah. Can we call
Uh,
them attributes?
Yeah, we can. No, I don't think maybe it's proper right now. But what basically, you have to kind of dive in a little bit deeper and kind of understand that, basically, contracts can access a key value store, right?
Okay.
So they
Mhm.
save their state in a key value store.
Okay.
What this is defining is that we're gonna save this struct called state
Mhm.
at a key called state. Now it's a little bit confusing because everything's named state here, or we have like three instances of state, right? But as we change, we look into the contract code, we'll kind of understand it a little bit more.
Mhm.
All
Okay.
right. So go ahead and go into contract.rs, which contains the meat of the logic, right? So there's a lot of boilerplate, as you can see on the top. You're basically importing like stuff that is used to create the contract. But the main important bits are in the uh, pub function instantiate, execute, and query. Can you go ahead and take a glance at them?
So first we'll go to instantiate
Mm-hmm.
state. So instantiate takes these
Right.
parameters.
Right.
Okay. Owner. And this state is derived from the state. which were declared in state.rs.
Right, it's a state struct. As you can see right here, it's similar to like new. It's like creating a new struct.
Mm-hmm.
Right. So we're creating a variable called state. We're assigning it the value of a struct, right? And that
Yeah.
struct contains count of the message count because the message is provided. As you look in, what is it? MSG. MSG is an instantiate message, right? So
Mm-hmm.
MSG actually contains the arguments to instantiate. Everything else is just boilerplate. So the deps and message info, all of those are just boilerplates, right? That kind of
Mm-hmm.
give sort of the environment context that it's executing, right?
Mm-hmm.
So can you kind of summarize line 25? What do you think is happening?
Okay. So it says that it is setting contract version. And what is set contract version?
If you click it,
Yeah,
I guess it right. So
it's
then it seems like it's just imported. So it seems like it's just calling something called set contract version. So this is extraneous. This is just part of some standard that all contracts have a name and version.
Mhm.
Right. So you can
So
ignore
it
that.
is
Right.
okay. So it's having storage, contract name, and contract version. I
Mhm.
think it's setting the contract version and then saving the contract, which we defined earlier with the state.
But it doesn't call that at all. So are you summarizing line 26? What's happening in line 26?
Yeah, exactly. So it's saving the state,
Right.
right?
Right.
And
Saving the
with
state.
contract, yeah.
So line 25 and line 26 are not related at all. You can actually just remove line 25 with nothing, with no consequence.
Oh, okay. So what does it actually does?
Oh, it
It
just
sets.
it just calls something in another crate CW2, which is a kind of standard for saving like contract name and version onto the blockchain.
Okay. Okay. So we can ignore it.
Hmm.
Okay. So the next part would be like saving the contract, which we without this state,
Right.
and then it's like, what is okay?
So okay, as you can see, can you look at the function signature of instantiate?
Yes.
Okay, so you see that we output a result of either response or contract error.
Yes. Okay. So responses of this type, which is of
Right.
okay,
So
type which is of this
results,
type.
you might know results. It's a monad. Basically, it can be one of two types. It could be an error, or it could be like a correct value, like
Mm-hmm.
if nothing goes wrong, or an error. So how errors work in Rust is typically using the result type.
Mm-hmm. So result type is containing response and contract error.
Right. So then in order to say that we were successful, we have to output a result type, right?
Mhm. Yeah. So okay means kind of a return.
So a result can be of two types. It can be an OK or an error, right? So then OK is
Okay.
of type of response. So if you look at OK, if you just control
Click it.
click, yeah,
No,
on
it's not
that,
clickable. It's not clickable.
yeah. So OK is basically is built into Rust, which is part of the result.
So okay, William, one doubt here. So
Yes.
okay can have two things, response or error.
No, no, no. A result can have two things: OK or an error. So a result.
Okay.
So this is an enum notation actually.
Mhm.
So if you replace the OK, right, and you
Mhm.
typed in ERR
Okay.
or capital ER, capital E,
Okay. That's all. It's
lowercase r,
case. Okay.
right. So that's the other thing to return, like if you want to return like an error.
Ah, okay. Okay. Okay.
Okay.
So I got it. So it might be okay or error.
Right,
And
exactly.
inside that, we wrap our response.
Yeah, we put our, yes, exactly.
Okay.
In the response, we create a new response. So this is kind of the builder syntax for response, right?
Mhm.
We add attributes, and attributes here are just like events, so contract events.
Okay.
Okay. So here we might want to log things, about the execution, such as, who sent, like what event was triggered, who sent what, right? That might be useful to record. So then later, when we're parsing the blockchain, we can extract those errors and kind of see what happened. Basically, it's kind of hard, kind of complicated to get into it, but if you think of like contract messages like functions, they can't actually return anything, right? Because what they return just gets saved to the blockchain. So because they don't return anything, we have to save the useful information about the computation into the logs, right? So just think that we can't really return anything, so we have to put it into to the event logs. So the event logs here are just called attributes, right? So something is recording. It's like what was called, who called it, what was the count, right? So we use add attribute, right? Okay, why don't you go into pub execute and then kind of just kind of see if you can understand it.
So again, it is having the result response contact error, which is pretty standard. Accepting these parameters, which is this looks same to instantiate message.
Yep. Except what? Except the execute message, right?
Yes. Except
Right.
execute message.
What's the difference between instantiate message and execute message?
These two are two different enums, right?
One is an enum and one is a struct. So you can think of an enum as, so in Rust, enums can be are quite complicated, as in like they can contain unit enums, or unit variants, struct variants, or tuple variants, right? Here we're unpacking struct variants. So this execute message could be of two types, right?
Execute message could be of two types, which is mentioned in
Right.
increment or reset. So okay, if we go to, there's something called match message,
Right.
which is having two functionalities, I guess, increment and reset.
Right. So then what the syntax does is basically, so match is a core, like it's like a switch in
Rust.
in Rust. So it's like a pattern matching. So depending on the type of variant that we encounter, we can kind of redirect, or we can output two different things, right? We can do try increment or try reset. Right. So what the match branches are doing on the left is kind of unpacking the values in the enum, and then forwarding them to what's on the right of the arrow. So, for example, in execute message increment, there's nothing to unpack because inside the increment does not take anything, right? It's just a blank struct. So then we just simply call try increment.
Okay. Try increment, try reset.
Okay. For the reset, inside, if you go into execute message reset, if you control click on the reset.
Okay. Why can't I go into any of the definitions? Is it reset?
Oh, I think it's because you're not loaded into a crate. So you've done Rust Analyzer, but can you just in your console, can you just do code space I? Oh, code space dot. Oh, you haven't installed. Can you install the code, or just open it in VS Code?
Is it an extension or something?
No. I think it's I think if you go on the top, like get the Apple menu, it should be under. It should be under terminal or terminal. No.
Oh.
On the right, terminal.
Okay, sorry. Okay, yeah.
Shit. How do you see? No, maybe not terminal. I think it's in.
Because for JavaScript it works out of the box.
Yeah, I know. But it says it's not command. I think you have to add the shell command into the thing. So I'm not sure how to do it. Let me check my own VS Code.
Yeah. Meanwhile, William, I mean,
Yeah.
do you think I should get the basics of Rust first, or
No.
do you think? Okay,
I
okay,
think it's very hard to go like, let's say it's hard to go. Okay, so Rust, I think it's easier to learn. Yeah, I think you definitely should get the basics of Rust, right? But let's do it after the tutorial. I mean, like there, it's a complicated syntax, but and it'd be helpful to have like a working knowledge of Rust, but it's not necessary to write basic smart contracts, and definitely not necessary for for the tutorial I'm giving.
hmm
Um,
yeah, yeah. After tutorial, I'm saying.
yeah, definitely. Yeah, just
Yeah,
like to get a working knowledge of Rust is probably definitely helpful. Yeah. Um. Okay. I think you're good so far, though. Like you've been following the code, or it doesn't look too scary, right?
yeah,
Sure, there's a bunch of like random like concepts you need to learn, but yeah, we can just walk through them right now, and then kind
yeah.
of.
Sure, sure.
How about let smart contract writing be your gateway into Rust?
hmm
Okay.
So we could write a new contract, but before that, can we fix this?
Yeah, I think you need to add code to path VS Code. Let's see. Okay, so can you do Command Shift P?
Yeah. Oh, sorry.
Command Shift P.
Yeah,
Okay,
yeah.
shell.
So
Yeah. Okay.
install code and
Yep. Okay.
okay.
Maybe.
Yeah,
Okay.
but
I,
it
th-
it got
I
opened
think
in
I
V.
think you should be able to type, go into source, go into contract again.
I'll do that. Yeah.
Okay, I think you should be able to. Yeah.
Okay, wait.
Well, the as
Contest
you can
and
see, Rust Analyzer is indexing right now, so yeah.
it's very different, William. I mean, I have done C++, but this syntax is
Mm-hmm. Yeah, but you'll learn to love it.
like how do people love Rust? I mean, the syntax is very.
It's beyond the syntax. I think it's once once you get a taste for Rust, like it just it just exposes you to ideas that about like safety that you never thought before, and you start to like you can't live without it. You will never go back to normal systems programming.
Oh,
Yeah,
really?
yeah, because like it eliminates a whole class of errors like memory safety. Um,
hmm
yeah, so it introduces new concepts and allows you to, well, it draws from the latest in programming language research. So you're able to use things like these like monads built into languages. Yeah, so people eventually like love it, even though right now it's like syntactically very noisy.
hmm
Um, the why we were, but can you see why we were trying to build a language for writing smart contracts? Because
Yeah, yeah, yeah,
you actually
yeah,
don't need all this Rust to express something simple, right?
yeah. And now I got it. Like if CW script is very intuitive, in the
Hmm.
sense it makes easy for people to write the contracts, right?
Hmm.
And behind the hood, it execute Rust.
Yeah, it outputs Rust. It outputs
Okay.
Rust, and then you have to build again. Yeah.
Yeah. Okay. So it's like a transpiler, like which changes your JavaScript code into Rust, and then we execute it on blockchain.
Right, right. But it's domain specific for cosmwasm.
Yeah.
Yeah. Okay.
Okay. Awesome.
Yeah, but I think Rust actually it's a great language to work with. It's just not great the API they've exposed, or it's just not satisfactory. It's not. I wouldn't want somebody writing contracts using this because they definitely don't scale, right?
Yeah.
Okay. As you can see, the complexity grows, and as you get into more complex things, like adding, it's quite low level, as you can see, and it
Yeah.
mixes things from different levels of abstraction.
Mhm.
Right. So, all right, let's go into. Okay, where were we before? I think we were in execute. Can you go back up?
Yeah.
Yeah. Okay, so can you control click reset yet? Yeah. Okay. So it brings you there.
Hmm.
Okay,
Which
if
is
you
inside execute.
right.
Sorry.
No, no, it's okay. I
S-
can see.
Yeah. Okay.
Okay.
So one question here, one quick question here, William.
Mhm.
So this whole thing, which Rust is trying to do on
Mhm.
Cosmosm,
Mhm.
we are trying to do same thing, but with decreased difficulty.
Decreased difficulty, decreased noise. As you can see, there's a lot of boilerplates that you don't necessarily need. What we want to do is we want to get the essence of your contract without writing anything more. So we want to go simpler, but no simpler than that.
Okay, okay. And is it like, can we write the contract using CW script right now? No?
We can write very simple contracts, but I'm kind of redesigning the language.
Hmm.
So it's going to be like a week out before I unveil the new design. But yeah,
And then we can
yeah,
eventually build our own contracts using CW script.
yeah, exactly. Right now, a sample contract works. I can send you a video if you've of the demo of the prototype that we built a couple months back before the
It's
crash.
on it's on YouTube, right?
Yeah, it's on YouTube. Yeah.
Yeah, yeah. Okay.
Okay. I'll send that to you after, and you can watch that
Sure.
just for comparison.
Yeah.
Okay. So let's go into so reset. Now we see that reset takes a parameter of count, right? As you can see, the Rust analyzer kind of has these like inlay hints, right, which kind of remind you of the type, right, in the code. So
Hmm.
it's a little bit helpful, but also like kind of sometimes could be a little bit wordy, right? Okay, so count is a type I32, right?
Hmm.
So then try reset. What does try reset take in?
Try reset is taking depth mutation, info, and count. What is depth here? Depth.
Yeah. So depths are um, they provide the interface to the cosmwasm API,
Hmm.
and it is injected by the blockchain. So let's say here we have three things. We have storage, API, and querier. So when the blockchain is loaded, it has a cosmwasm like sort of VM, and it injects a handle that allows the contract to interact with the blockchain. So just think of depths as dependencies injected by the chain or the host environment.
Okay. So we get back to this execute message, which takes the, if we go to reset, it takes the parameter of count
Right.
of I32,
Mm-hmm.
right?
Mm-hmm.
And then we go back and there is a message, which is like function, I guess,
Right.
which is try reset. And where do we declare this try reset? Over here. Okay.
Mm-hmm. Right. So let's go into try increment. What do you think it's doing? Now, first of all,
Yeah.
try to unpack what's happening in line 48 to 51.
Mhm. I think it's updating the state by one, by incrementing the state by one,
Mm-hmm.
which is a count. So state have a count,
Right.
which is this count,
Right.
I32 type.
Mm-hmm.
So it is incrementing that count.
Yeah. So you can see just a little bit, just a reminder of like why we're building CW script is that when even when we want to state something as simple as state.count plus equals 1, we have to
Mhm.
create this like state.update thing. We need to pass in storage, a handle to the
Yeah.
storage. We need to add like a closure
Mhm.
from the state, right, and then like annotate it with um, all these results, right? So yes,
Mm.
it's very coherent in Rust, right? And if you're a Rust developer, it makes sense. If you understand also cosmwasm how it's built, it also makes sense. But for a normal contract developer, it makes it hard to visually parse what's going on, right? So it's
Mm.
easy. So I like to say that cosmwasm is easy to write, but it's hard to kind of piece back what's going on. And you can see, contracts are supposed to be secure,
Mhm.
very auditable, readable, right? But here it's kind of very hard to kind of visually parse and rebuild or reconstruct what the original intent is, right? So for each line, you have to
Yes.
comb through it very, very carefully.
And one question here, William. Like Terra does the same work, right? It is used for building the contracts.
Yes.
So why, like how CW script is different from Terra?
Um, what do you mean? Terra is a blockchain, right, that has cosmwasm enabled. So cosmwasm is a module that enables Cosmos-based change, such as Terra,
Mhm.
or any other chain that wants to add smart contract functionality to instantly embed it, and it's like plug and play allows, suddenly allows smart contracts to be in the chain. So all these contracts could work on different chains if they have the cosmwasm module.
Okay. Okay. And we use Terra.js for developing the contracts as well. Am I right?
We don't. Terra.js is for interacting with the node. So blockchain
Ah, okay.
is coordinated by a lot of nodes that are connected together, right, using like
Yeah.
peer exchange, right?
Mm-hmm.
So in order to interact with the contract, you have to call a node. The node packages your message and tries to process it, or it propagates the message to a validator who's basically validating the blocks. So in order to interact with the contract, you use a client, right? And
Mm-hmm.
the client might be Station, it could be Station extension, or it could be Terra.js. Actually, Terra Station and Terra Station extension are implemented using Terra.js.
Ah, okay. These are the clients. So
Right.
when I went through their documentation,
Hmm.
it was like the Derek started set up a project and using what was that? If I go back, yeah, smart contracts, right?
Hmm.
Okay, it shows how to perform tasks related to whatever smart
Right,
contracts.
right.
Okay.
So this is like how you can upload a contract, create a contract, but that contract needs to exist, or the contract needs to be coded up already. So it's like once you have a contract and you build a contract, how do you upload that to the blockchain?
Oh, okay. Okay. And
Okay.
how do we build that contract right now using Rust only?
Yeah, using Rest only.
Oh, okay.
All right.
Interesting.
Right, and
So,
then we'll go into that a bit later to see how it all connects together.
okay, sure.
Okay, so increment. Basically, yes, you're right. Lines 48 to 51. In a kind of convoluted way, just update the state by one, right?
Mhm.
Okay, can you kind of go ahead and explain lines 57 to 64?
Like 57 to 64. Okay. So it is trying to reset. So it is updating the state again,
Mm-hmm.
right? And if the sender info is not equal to state owner, so the one is trying to send
Mm-hmm.
is not equal. Okay, so what is trying to do? So one who sent the request to reset is not the owner,
Mm-hmm.
then it errors out.
Correct.
Right? And if it does, then the count is this is the current count, which is state.count is equal to count, and count is passed on to the reset parameter. So we can reset it with any value,
Right.
right? So okay,
Okay. Cool. All right. Now, can you go into query?
yeah.
Yeah. So as you can see, the query is a little bit different. Rather than taking info, right? It's depths and there's no info,
Hmm?
right? There's depths and env, but there's no info. Message intro. But that's because there's no information about who is sending the message because it doesn't matter, right? Because so basically, in order to instantiate or execute a message, you're updating a blockchain state, right? So you have to
Mhm.
pay some fee. So you have to create a transaction in order to instantiate or update a contract. However, with a query, since it's read only, you don't need to make a transaction in order to interact with the contract if you're using a query.
Okay, okay.
Right. So here we only have one called get count, right? And there's something called an STD result. It's similar to result, but um, instead of returning a contract error, it returns like an STD error.
Mhm.
And binary. So binary is just like just bytes. Okay.
Okay.
So what does query count do?
Again, it's as a query count. So query count is having. So it is just returning the count, the current state of the count, right?
Right.
But it is like it should be like a simple getter message. But now I'm realizing there's like a lot of boilerplate and
Right.
unrequired.
That kind of obscures
con-
the yeah. If
Yeah.
you can imagine this is just one simple query message. What do you think like something more complicated with more logic might be, right? It expands and it grows exponentially as even and when you get to contracts they call other contracts, they call other contracts, and then it gets a little bit hairy, right?
Hmm. Yeah. Yeah. Yeah.
Okay, so why don't we build this contract and try to interact with it from Terra Station? So can you go into developing.md?
Oh, development.
Right.
Yeah.
So you have to kind of go scroll a little bit down. You should see something that starts with Docker ARM64 version. The ARM 60 right there. Yeah, right there. This
Yeah.
is so. Go ahead and copy that Docker script and paste
Hmm.
that into your terminal.
This is.
No, no, no.
Oh, sorry. Yeah. Yeah.
Yeah,
The terminal of VS Code or
yeah, VS Code.
okay. So we are going to have a new directory.
No, no, just
Okay, same.
yeah, it has to be run in the contract root create root.
You go to find image. It will pulling up the image from. Okay. So, William, how do you went about learning out of Rust and creating contracts and stuff?
Well, I kind of designed the SDKs for Terra.js. So yeah, I just learned it just
Hmm.
by making contracts and reading and trial and error.
Because I think like it's very different from the web app word which we see.
It is, but we're trying to bridge that gap.
Yesterday, Marco mentioned one more thing,
Hmm.
which is like right now the UI experience for the blockchain Web3 apps
Yeah.
is very shitty.
Yes.
So we are trying to recreate that experience and have a nice experience for Web3 apps.
Of course. Yeah, I think that a lot of blockchain is trying to solve like a basic UI problem. And I think that the Terra apps have done a pretty good job, but it can still be
Mhm.
improved. It's still not as as easy as interacting with like PayPal.
Hmm. Okay. So do you think, William, down the line we'll be having more React work on the front end side or that sort of
Yes,
stuff?
yes. In fact I have something lined up for you in terms of React. I want us to build like a sort of React component library for and hook library for building apps that interact with smart contracts.
Okay,
Yeah,
nice,
yeah.
nice. So we have this done. So, so
Yeah.
it did. If yeah, we do have the images of
Yep.
cosmos.
But if you go back, what was created from the that is if you can look back up the trace, you can see that there what it did was it executed cargo and then it did a specific like script that like compiled it and also optimized it because normally you're going to be compiling it and it's going to be like a binary of like 2 or 3 megabytes. It's going to compress
Mhm.
that by optimizing it into something of a couple kilobytes. So the
Mhm.
output should be available in the folder called artifacts. If you go scroll up,
Ah, okay.
the folder on the left.
Oh, oh, sorry. Okay. Artifacts.
Yeah, so you see like hello world
Oh,
wasm,
awesome.
right.
Yeah.
Yeah, so let's kind of go and interact with it from Terra Station. So go ahead and go into Terra Station.
Okay. Yeah.
All right. Are you on the testnet? Can you change it to the testnet?
Okay. How do we change that?
Go on the right. Test. I think you clicked on your wallet
Yeah.
on the right hand upper side.
Yeah, I did. It's on the wallet. Oh, like this?
I think you can manage your wallet.
Yeah.
Shit. Okay, click the Terra 2.0.
Okay. Oh, it's
Fuck.
not clickable.
Oh, it's not clickable. Shit. They make it so hard. Okay. Um. All right, do you have the station extension?
We can do that. I did it for just desktop.
Okay, go ahead and go station extension. You have to search in the Chrome Web Store. Oh, okay.
Oh.
Actually, here's okay. If you press connect, it will uh go up maybe. Wallet connect.
Mm-hmm.
Oh shit. No. I think you need to get the browser extension called Terra Station extension.
Yeah.
Chrome, yep.
Yeah. Yeah. It's there.
Okay. Why don't you create a new wallet and this time you memorize the mnemonic, or
Yeah, I
or, or,
did.
ju- or just
I
copy.
did.
Okay. Okay. If you want to load up your previous wallet, go ahead. And this should be a throwaway because this thing is recorded. So
Yeah.
yeah.
Okay. Hello, wallet. You had your demo? Hello?
Save it.
What is sixth or album?
Album.
Which first for 1 3. Ah, okay. Really?
Okay. Cool. Why don't you copy that address?
Is this one?
Yes.
Mhm.
Okay. Go press the gear icon on the. Yeah. Change it to testnet. Okay. Go into a new tab and type in faucet.terra.money.
Dot honey.
Mm-hmm. Yeah, go ahead and put in your testnet address.
Send me tokens.
Yes. All right, it's gonna send some Luna, and you're gonna be getting that in the next 5 seconds. So the blockchain
Okay.
is, like you posted a transaction, but it's waiting until gets included into a block, right?
Yeah. So should I refresh it in order to see the point? Yeah, I did. I did.
Okay, so now you have the 5 Luna. Why don't we go back to Terra Station in the browser?
Mm-hmm.
Just go to Station, and you might want to pin Terra Station to your Chrome,
Okay.
or
What is the Terra dot station?
Station the Terra the money.
Yeah.
You can. Why don't you press the plugin icon and just pin that to your extensions
Plugin icon.
on Chrome. The jigsaw puzzle piece.
Oh, puzzle piece. Okay.
Just pin that.
Yeah.
Okay, cool. Connect. Press connect. And Terra Station wallet. Yep. Okay. So now you can interact with it from this web app. Go ahead and go into contract tab and press upload. And you need to upload a WASM file now. So go ahead and upload that artifacts .wasm file.
Yeah. Yeah.
Mm-hmm.
Yeah.
Okay, good. All right.
Fees is okay. There's a fee.
Yes.
Okay. And do we see it on the? Okay, we have.
Okay, then you have this mount. Okay, great. So if now where did the WASM file go, right? So you can check history, and what you've done is you've stored it, but then go ahead and click the hash on the top. So each transaction is denoted by its hash, which is unique. If you go down all the way to show logs, you can see that it stored a code called code ID. So these are the logs that we talked about earlier. So each is basically a key value pair,
Yeah.
right? So here we have action, the store code. The thing that's important to us is the code ID at the bottom.
Mm-hmm.
So go ahead and take a note of that code ID and copy that. If you go back to the station thing instance, you can go to contract. Now you can instantiate, right?
Oh.
Okay, so you don't need to put any admin code ID. So an admin basically is the person who's able to basically update the contract if there's any out changes to the code. But we don't need to do that right now. What we can do is we can just play around with the contract. So when you initialize the contract, this expects a JSON message, right?
Mm-hmm.
So it's not shown here, but if you go back to the VS Code, what does it expect in the instantiate message?
Message account. Instantiate message. It expects account.
Right, an account, right. So what you don't see right here is something called serialize, deserialize. These are automatically implemented for you, but basically it serializes this into JSON, right? So this and deserializes it from JSON. So how this works out in JSON is just an object with one key called count and then a number. So you can go ahead and maybe set the count to whatever you want, as long as it's a I32. So you can type in JSON, right?
Okay. So JSON, like a JSON doc.
Yes. Count.
Okay.
Yeah. So it's also not going to accept the string. It's going to complain if it's a string. It's going to be only. So the value it can't be a string. It's an I32, right? Yeah. So go ahead and type in a number. Okay. So here you don't need to put any Luna, but basically you can also send coins to the chain, and the label is optional.
Mm-hmm. So estimating fee.
Huh.
Label is required.
Oh, it is required. So just type in anything. Okay.
So we should submit it now?
Yeah, submit it. Try that thing again. Sometimes you get this error. Yeah, this is part of the UX stuff, but basically there's a bunch of node syncing and yeah. Okay.
Yeah.
Cool. Now we have if we go back to the history and we click on that,
hash.
Yeah, let's find the contract address of the thing that we created.
So the label and everything.
No, yeah, but where's if you go down, right? We created something called contract address, right?
Yeah.
Yeah. Why don't you take that contract now? Copy that contract.
Clickable.
Yep. So this contract address, copy this address because we're going to try to interact with it, right? So if you go to the query right here, if you press query, you can actually type in a query message. So what is the query message
type.
Yeah. This is called get count, right?
Yeah, get count.
Right, but you see that line on 17? It says Serde rename all to snake case. So
Yeah.
all of the members will be renamed to snake case.
Okay.
Yeah. So go ahead and just make a plain object with
Mm-hmm.
the key get count in snake case. Don't forget to snake case. So using underscores.
Hi.
Yeah.
Hyphen. Okay. Oh, sorry. Underscores. Yeah.
Yeah.
Get count.
Lowercase as well.
Oh. Okay. Yeah. Yeah.
And wrap it in quotes.
Okay. Bit tough to follow, but yeah. Yeah.
Okay, and then that should have a value of an empty object.
Empty object. Okay.
Yep.
Because it's
Right.
okay. So next, yeah, it gives us 12, which we instantiated.
Yes.
Right. So,
Right. Now let's go back into station.
mm-hmm. With us, yeah.
I go to contract tab. Now let's search up that contract address that we saved. Okay, it's there. So what we can do is we can execute now, right?
Mm-hmm.
So why don't we try something? Like we can. So what? Let's try the increment.
Oh, increment. Okay. So, yeah, this one, right?
Right.
So increment is having an empty value, and but it is also snake case, but we don't need that. Increment.
Yeah. Don't
Right.
forget the quotes because it's
Yeah,
JSON.
yeah, yeah.
Mm-hmm.
And
Empty object. Yes.
Luna, we have to.
No, we don't. This is basically you can also pay when you send an execute message because some executions require you to pay something, right? Like for
Mhm.
example, you're depositing money. Yeah.
Okay, but why do we have a fee then for executing
Yeah, because
message?
we have a fee for every transaction. So anything that updates the state of the blockchain or changes the state needs to be put in a transaction, and every transaction has a fee, which is the computation used. So
Mm.
in order to process the transaction and to prevent
Mhm.
spam, every transaction has a fee.
Okay, okay.
Yeah, which is kind of proportional to how much computation will be required for the execution of that transaction.
So we submitted.
Yep.
Successful.
Okay. So what do you think is going to happen now if we go back to the contract page?
It will like give us the 13 as value because we incremented it.
Maybe try it.
Oh no, it didn't.
No, that's the init message, right? In order to get the current state of it, we have to query it.
Query. Yeah, yeah, yeah. Get count was snake case. There was an empty object and submit. Yeah, we have 13. Yeah.
Cool, cool. Maybe you can try a reset now and see what it's going to be.
So we have to execute once
Hmm.
again.
Right.
Okay. And what was reset? And of a count type, right? Let's reset it to 6. So reset with count type. So when we type this, we have to also count, right? So it should be again quoted into like it should be
Yes.
inside quotes, right?
Yes.
Mhm. Okay. And like let's reset it to 6 and submit it.
Hmm.
Okay, it's done. We query again. Search your contract, query, and we say, hey, get us the count. Um, then not there. Oh, why did it say to?
Maybe we can try to submit it again. Sometimes it doesn't. Propagate.
Yeah.
Okay, cool.
Uh,
Yeah, so because a blockchain is a decentralized network, so it takes time for all the nodes to propagate with the latest with consensus, right? Some nodes may be lagging behind, and because this is load balanced, we might be hitting a different node, which might not have a chance to propagate.
updated.
Yeah, exactly. Yeah, that's why when you're using the exchange, sometimes it waits for a certain number of confirmations, right,
Mm-hmm.
before it's able to disperse your money or deposit money.
Mm-hmm. Mm-hmm.
Right.
So I think I understood a small part of it, although there may be some bits and pieces.
Mm-hmm.
It needs to be understood more.
Right. So how about we try something? Let's try some just trying editing the contract just a little bit.
Yeah.
Can you try adding a um, multiply by two message? So don't try to copy and paste anything. Just type it out. Maybe make a new function like multiply two and add one.
Mm-hmm.
Right.
So we
So
need to
we
have a new enum.
no, we don't need to make a new enum. We need to make a new enum variant. So it has to be in which one? Is it an instantiate, execute,
No,
or query?
execute.
Right, because we're updating the state.
Yeah. So
Okay.
multiply, let's say multiply,
Okay.
right? And it will be an object.
Uh huh. And
Okay, now we need to multiply the current count with 2.
we could right. Let's
So,
do that. So does it need
okay,
any arguments?
yeah,
Maybe for the sake of it, how about we call it multiply and add, and it takes an A and B, right?
okay. Multiply and add.
Yeah, but we also want to follow the convention where we're using like
The snake case.
no, it's already snake. So all of these Pascal cases, because Rust conventionally uses Pascal case,
Mm-hmm.
these will be converted into snake case by Serde, which is a Serde, which is serialized, deserialized. This is a library um, for for serialization and deserialization of objects in Rust.
Mm-hmm. Okay, so val 1 and val 2.
Sure, but this is wrong syntax. Right.
Okay.
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 So you basically copy the format of reset.
Ah, okay.
Yeah.
So okay, so count is a parameter
Yeah.
that
Exactly.
reset accept.
Yes.
Okay, okay. So basically, there will be val 1 of
Yeah.
type integer.
Sure. Or it's called I32. So
Oh, it's called I32.
yeah.
Okay. And we can have a comma and say there's a val 2 of I32 again.
Hmm.
And how do we return the
So what we have to do is we have to update the code in the respective parts, right? So we have to.
okay.
So can you
Okay.
figure it out?
So yeah, so if you go to there is a function called reset,
No, no.
which is
These are the tests. If you go all
oh
the way up.
sorry. Yeah. So this there's a function called try reset, try increment, and
Mm-hmm.
we have a same functionality for the particular multiply and add.
Uh huh. So
So
instead of copying and pasting, try to just write it out just to get a feel for it.
yeah, this feel is very different actually.
Mm-hmm.
Why everything is try and try? Is there
It's
any
just a
convention?
naming convention. I think it's you don't need to name it try. I don't. I think it's just because it might return an error.
Mhm. Okay. So and it will return a result of try. response, which is like pretty standard. I'm just following the
Mm-hmm.
previous function.
Yep.
So depths, depths. And do we need info? No, right? We just need a count.
Mm-hmm.
It's a iterative type. But also,
Do
where
we?
to value?
Here's where you pass them in.
Val one, 552, Val two, 552, and that's it, right?
Mm-hmm.
And now we return something.
Mm-hmm.
So, okay, there is called state.update.
Right.
So we can update the value of count with the multiplication of these value, right?
Multiply and add.
Yeah, multiply that.
Right. So try it.
So straight. Okay. I'm just following the previous. So pattern, um, yeah. So state.count can be is progress state. Can we use shorthand notation over here?
Sure.
So I'll just multiply and add the previous state value. So that's all.
Okay.
And
I think
we
it's.
just
I think we should maybe do. Oh, it doesn't really matter. I think we do state.count equals state.count times val1, and then plus val2 or something like that, right?
we can also do that.
Yeah. Or just add. Okay, yeah, sure. Who cares? Okay.
Or we can also add like this, right?
Yeah, but um, I think that
Okay,
may. Okay.
it doesn't matter.
It doesn't matter. We're just trying to just okay.
And we have functionality like this, and like it this. Oh, it didn't there actually. Yeah, and then we send okay response. Right.
Uh huh. Maybe try adding the attributes of val1 and val2 so that those are also
Can we add the value here? Right?
yeah.
Like this.
I think you need to convert them to string, so .to string.
Okay,
Mm-hmm.
that's there, and we can also add attribute again, right?
Mm-hmm.
And we can say value.
Yeah. Do you see how your type hints are not that great? That's because um, your current project is not loaded in. Your current project's root is not a crate. That's why Rust Analyzer is not working.
Okay.
So maybe you can save this and then load it in the other one just to see your like IntelliSense code hints.
Okay, I'll just so can we finish this one? Please?
Sure, sure.
Yeah. So I have this is done. Multiply and add.
Mm-hmm.
And we have multiplied it, added with the state, and added the attributes.
Mm-hmm.
Right. So I think we need to build it again and then upload that
Yeah.
Cosmos file. Right.
Sure. Yep.
So,
Yeah. And can you maybe also add a query called query owner or get
oh,
owner?
so inside
Mm-hmm.
we can have get owner. And this will serve query count. You can also have function which says query owner. Does that make sense?
Yep.
Okay, that response. And now, okay, what is this one? Okay, it's a type get count response. So we don't need get count response. We need, oh, okay. They have this kind of response structure, right? We also need to define a structure of the get owner.
Right. So as you see for query messages, because they actually return data back, you have to create the structure that they'll return back.
So it's a type of
Right.
response which we are printing.
Correct. And you also need to copy that long derived macro, but
Oh, okay.
yeah.
I think CW script is going to simplify everything.
Because even though it's kind of hard to see it right now, but there is some you can sense that there's a lot of patterns going on, and
Yeah.
you know it's not going to be as easy as like copy and paste patterns or macros, but once we break down the structure of code, we can reassemble it as Rust.
Yeah. So how do we like there is a string type?
Uh, there is a string type, yes, capital S.
I did type it like that. Okay. It didn't give me the suggestion. So we have this and we can use get owner response.
Yeah, but we might need to import it.
Yeah, we did. We need to get owner. Where's, how do we import things? Okay, I'll just check it.
Go all the way up. It's,
Why I can't see?
that's because, like I said, you're not loaded in a VS Code where the your workspace folder is a crate. So remember when I think you've opened it in another code browser, in another instance of VS
Window.
Code. Yeah, right.
Yeah.
In the other window, it should be proper.
Okay. So get owner response. I've imported it.
Mm-hmm.
So what do I do now? Basically, I need to load the state. So if I see state, no, where is having owner? Okay, I'll go to state, and state is having owner.
Mm-hmm.
So I can extract out owner from state.
Yes.
And so what state is going to state upload storage. I think one thing which is hard here is William like trying to visualize everything which is going under hood.
Exactly. Or even seeing the signal from the noise.
Yeah, owner. mm, Did I get owner? Owner history. Okay. I'll just take state. Does that sounds okay?
Looks good.
Yeah,
See if it compiles.
sure. We need to Docker.
Yep.
Oh, sorry. We also had one.
Yeah, its cargo wasm was the short one, but it does not produce an optimized binary.
Okay, okay. I'll just switch off on this, and there is state dot. Oh, so in if I got state, it's type of address, and I
Right.
defined it type of string.
Right.
So it should be type of address, right?
Or you could do a string by converting it into a string. all the same, it kind of serializes as a string. So
Okay. So maybe just for the sake of simplicity, I'll
sure,
just.
sure, I think that works.
Um, I think I have missed it somewhere. Removing this semicolon,
Yes.
multiply.
So you have a semicolon somewhere at the end of OK. So the thing
Yeah.
in Rust is basically everything is sort of like an expression, right?
Mhm.
So a convention is instead of typing return, the last one is, it's like Ruby where the last one is the return type, right? And because you use it in semicolon, you kind of like silenced the return type,
Mhm.
right?
So, oh, unused imports is saying
It's okay. I don't think it matters. It still builds, right?
it is a warning. Okay.
No,
How do we check that this wasm was
no. Can you
uh,
go all the way down? It should.
could not compile hello due to previous
Is adder
vulnerability?
is it's the error, not the warning.
Oh, okay. Consider importing this struct. Oh, okay. We haven't imported this, right?
Right.
So state you can use this.
I think it's in complaining in message.
Message.rs. Yeah, we use address, right?
Yeah,
So
but
we can.
address in. Yep.
Okay. Query message is defined here
So you did not update the query function.
in contract rs.
Yes. Go to the query
And
function. Right. Because so you wrote the query owner, but you did not specify
uh,
where that you did not, right.
query. Oh, okay.
Yeah.
We can leave query owner.
Query message. No,
Yeah,
no,
query
no.
message. Okay, let me check. Okay, query message has two types: get counter, get owner. Right.
Right.
Okay. Okay. Sorry. So again, query message we should type like this.
Mm-hmm.
Get owner. Okay, pretty, pretty. And binary. What does this two binary means?
So basically, it converts that into binary, which is just binary encoding of the bytes. So because it's streaming as data over the wire.
Okay, and also we have a space here.
Yeah. Basically, this allows for arbitrary JSON output. Right. Or yeah. Mm-hmm.
Execute message is different. Okay, it's the same here. Multiply, add, execute message.
Right. So there's a lot of boilerplate and leaves your code kind of fragmented because you need to change one thing, you have to change it in several locations, right?
Yes. Um, um,
I think you've added an extra space.
okay.
Yeah.
Where? Here?
On the line before.
Oh, sorry.
Yeah.
And it complains about extra space, right?
Yes.
Yeah, pretty much. I mean, tips. No. And all the contracts have been like till now on the Cosmos have been developed using Rust.
Yes.
It might be pretty tough actually. So how about this William? Like how Solidity differs from it?
How what?
Solidity, like on Ethereum we use Solidity,
Yes.
right? So is
Yes.
it like very similar to JavaScript and stuff?
The syntax is more similar to JavaScript, but the concepts are sort of similar here.
Mm-hmm.
Um, so all contracts, you can best think of them like a singleton. There's several important architectural differences. Rust is obviously much more generic than Solidity, which is kind of designed to work with the language abstract machine of the Ethereum virtual machine, which is the EVM, right? So
Hmm.
Solidity is designed for the EVM, so it has language constructs for targeting that specific architecture. WASM is, it's just like a is more close to native machines, or it's meant to be run on native machines. So it's sort of like the generic. It's sort of like supposed to be the universal like portable execution format. So what wasn't quite interesting, I suggest you to go in a little bit on it and kind of understand what WASM is, how it
Hmm.
works.
Hmm.
Yeah.
So we uploaded this WASM file.
Right now you need to instantiate it with the code ID.
So we go to this contract, right? Not this. I forgot that. Like William, how did we do
Is
this?
in the contract tab of
Okay. Yeah. Oh, instantiate. Okay. Yeah, so instantiate message should be anything.
the instantiate message, which is like count.
I need to see it again. Okay. Hmm? So now we go back to contract. We instantiated it, but we didn't copy the hash.
You need to go back into your history and then find the contract ID or contract address. Yeah. So go into that transaction, go into some looking through in the details and see if find the contract address.
Mhm.
I think
Oh,
the
I got.
spaces.
Yeah. Yeah. So we can query, right?
Hmm.
Okay, get owner. Yeah, owner is this one. We're
Hmm.
able to get it. Now execute our multiply and add function.
Yeah. Try multiply and add.
It should be snake case, right?
Yes.
Now it is passing two values. This is val1. It
Hmm.
should be again quotes
Yeah, I think so. Yep.
true. Val2. For the
Okay.
previous value was 2. So 612.
Hmm.
Okay. So we can fetch count again. Okay. Oh, count is 6. I think it was 1. So it's
Yeah.
6 now.
Yep. Cool.
Right.
All right. And maybe get owner as well.
Yeah, we did that. Just do it again. Yeah, we got on.
Cool. Cool. All right. So there you have it. Like that's how smart contracts work from a high level overview with the simple smart contract. Um, yeah. So
I'm just
right. Okay. So the project that I've assigned to you is, and for you and Boone and the new guy as well. I want you to kind of look at cosmwasm-vm-js, which is a library I wrote, or just figured out how to run cosmwasm binaries in JavaScript.
Mhm.
So I think what we're gonna do is just basically just I'm just gonna show you how I'm not gonna run through the whole thing. I just want you to try using your contract with cosmwasm-vm-js. If you can clone that repository,
Yeah. So let me go to
should
GitHub.
be yep. Think turn one.
Yeah,
Mm-hmm.
this is their cosmwasm-vm-js.
Yeah.
I'll just clone it.
Mm-hmm.
Sure. It's simple. Less we raise this and
Okay.
you have this. Yeah.
All right. So go ahead and go into that. Yeah.
Okay.
Yeah. Go ahead and yarn install within the directory,
Mhm.
or just yarn.
Oh, yeah, and it's not stop. npm
npmi.
yeah. Should I install Yarn? Yeah.
No, npmi dash g,
Yeah.
or
So
just yeah,
npmi. Yeah.
and npm test or npm run test.
Meanwhile, I'll also install Yarn. Yeah. So we have it. It's taking some time too. So why both Yarn and npm? You know?
No, I think I just used yarn here. It's just the script for testing it is run with yarn.
Ah, okay. So had your dinner, William?
I did, yes. Right, it's a lot. It's a lot to go through. It's almost 2 hours.
Yeah,
Yeah,
exactly.
yeah, it's good intellectual stamina.
Yeah, we have it.
Okay, go ahead and just do npm run test. Yeah.
Yeah.
Okay, so why don't you just replace? So you see where it says cosmwasm-vm test.wasm? Can you replace that wasm file with, or can you add a replace that wasm file right here with a copy of your smart contract? So you might need to go into your Finder and
Mm-hmm. Okay. So basically, in the mock environment, we have this address, right?
yeah.
So we need to replace this address.
Don't necessarily no, because we're not connected to the blockchain. So this is all local.
Yeah.
This
Okay.
does
Okay.
this does not interact with the blockchain at all. So I created
Yeah.
a way to just execute WASM from within JavaScript.
Okay. We need to change this file.
Yeah,
Right. So what I'll do is
use
just
Finder. Or,
yeah, yeah. So yeah, we have possible. So
I think it's in contracts. You might want to make a if you go to on the top menu bar it says go
go
and then go to
folder.
yeah folder and just put your like Yogesh
Yeah.
right. You can maybe save that into your favorites because like
Yes.
no
Yeah.
not
We'll be
code
using
yeah exactly.
artifacts.
Yep.
This one, and now we go to. Okay, I'll just okay. In here we have this file. We
Yeah
can also place this file.
right and then just change the test.
Exactly. So to file. And let's change the name now.
Mm-hmm.
Mhm. Yeah. So yeah,
Okay.
yeah, done.
Cool. So what can you read what's happening in the what does cosmwasm-vm do in the terminal? What does it print out?
Prints out messages, attribute. Okay. It prints out the owner and the count, which is a query.
Mm-hmm.
Okay, let's go to the top.
Right. So
It writes DB write. So it's writing something on the contract and it gets the state.
so I've in this implementation I've kind of I've replaced the key value store with some instrumented version or I've replaced the wasm imports with instrumented versions that kind of output what's happening, right? But the idea is that we're going to complete the implementation of the cosmwasm VM inside JavaScript. So if you go in vm.ts, it has the implementation of cosmwasm VM in TypeScript. And then what we're going to do is we're going to create a web UI around this such that we can do everything
Interact
from
with.
like
Yeah.
look at what is the state of the key value store, add breakpoints and inspect the memory, inspect any errors and inspect anything that's logged, right? And
Mm-hmm.
then
Mm-hmm.
so this makes it a lot more repeatable.
Mm-hmm.
And now I think you should get enough context to understand the Notion document.
Yeah. Yeah.
Okay, cool. So next time I'll go into like how to interact with JS. Maybe you can try the JS example, Terra JS, and how to interactively or how to programmatically interact with the contracts.
Mm-hmm.
Yeah,
Yeah.
maybe you can do that, and then we can review tomorrow and see your progress on that. And then I can go into a little bit more in depth on the cosmwasm-vm-js project, and you can sync with Boone on how to collaborate for that. But yeah, I guess like this is enough to understand how Cosmwasm works. Maybe not too deep on behind the scenes. I
Mm-hmm.
think the debugger project will kind of really teach you what's going on behind the scenes because it'll require you to dig into a little bit of the code. Um, so I recommend learning a bit about WASM, reading over the Notion documents that I sent over today.
Mm-hmm.
Yeah, cool.
Yeah. I think that's pretty mind-boggling exercise.
Okay, but good. I think you followed along really well.
Mm-hmm.
Yeah. You didn't make as many mistakes as like like some of the other candidates. So
Okay.
it's
Yeah.
yeah. So I think Your attention to detail is very good.
So I think once we get started with Cosmos VMJS, so over here, William,
Hmm.
most of the work will be in JavaScript, I guess.
Yes.
Okay, I think because and the web part, who's dealing with the web part?
I think that'll be you and Boone.
Okay,
Yeah. So
that's great.
I've not. I think I'm going to leave this as. Well, I want you to kind of brainstorm on the UI layout and design.
Yeah, yeah.
Yeah, it shouldn't be too hard. It shouldn't probably. It's just to showcase the power of this tool,
Mm-hmm.
right? Because here we can execute, we can change the environment, we can do that, and we can hook that up to a UI so that users can do that interactively in the browser rather than writing Rust or manually having going to go through transactions, right?
Yeah, yeah, yeah. Makes sense.
Cool. All right.
So yeah, I'll stop sharing my screen.
All right, and I'll